Hey everyone, what is happening? Well, today we're going to be looking at covalent compounds. Now, we've looked at ionic compounds, we've looked at ionic compounds with multivalent metals, meaning that there's different versions of that metal. We've also looked at polyatomic ions. Now what we're going to be doing is just strictly working with nonmetals and nonmetals. So covalent compounds are made up of two nonmetal elements. All right, so let's just write in nonmetal plus nonmetal. That means you're only going to be dealing with the right-hand side of the periodic table. So atoms in covalent bonds don't join by forming ions. Instead, they connect chemically by sharing their electrons. That's the key difference. Ionic, they gain or lose electrons, and covalent, they share electrons. Now, we use a different system of naming for covalent compounds than we would use for ionic compounds. For example, we've got hydrogen peroxide, which is H2O2. This is a liquid that we put into our cuts or bruises, things like that, and it helps reduce the bacteria numbers. And so we never ever reduce the numbers. We just always leave them the way they are. So the prefixes we use for naming covalent compounds can be found on your periodic table booklet, and it looks just like this. So we've got the part where the polyatomic ions are. There's some prefixes right here, and we can see that 1 means mono, 2 means di, 3 is tri, 4 is tetra, 5 is penta, just like pentagon, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So try to find that in your periodic table booklet. So using those prefixes, we can write the name of a binary compound or covalent compound. Now, binary means two. The first element always gets its own name. So here's the rules. The first element gets its own name. We only use the prefix if there's more than one of the first element. And then the second element gets the prefix, so it could be mono, di, tri, tetra, penta, and so on, and we end it in "ide." So for example, CO, we've got one carbon and we've got one oxygen. So the first element gets its own name, and we only use the prefixes if there's more than one in the first. So now we've got one oxygen, so we're going to put monoxide. Next, we've got N2O3. So our first element is nitrogen, and we've got two of them, so we need to name it dinitrogen. And then we've got three oxygens, so we go trioxide. You'll notice we used the prefix in the second element, and we changed the ending to "ide." Let's check it to the next page, please. So we've done the naming. Now we're going to write the formula from the names of a binary covalent compound. We use the prefixes to tell us how many of each element of each atom there is, and then do not reduce the formula the way we do an ionic compound. So we've got nitrogen tribromide. So we've got NBr3. And that tells us that there are one nitrogen and three bromides. This next one, we've got disulfur decafluoride. So we've got S2, that's two S's, and fluorine, we've got 10 of them. Next, we've got diphosphorus pentaoxide, so a di and a penta. So we've got P2 and 5 oxygens, so we go O5. Now remember, you must check to see whether a compound is ionic or covalent. That's always the first thing we do. Remember that ionic is metal plus a nonmetal, and covalent is nonmetal, nonmetal, so that we know which of the two naming systems to use. So let's recap. An ionic compound contains a metal and a nonmetal. It contains a polyatomic ion. You can tell if there's a polyatomic ion present because the compound will contain more than two elements. And they might have Roman numerals in their name. This is a multivalent metal. And in covalent, it only contains nonmetals, and it does not contain polyatomic ions, and it never has Roman numerals in it. All right, have a good rest of the day.